Alright, so now we're going to talk about, this is lesson 5.4. Alright, so we're going to analyze graphs of polynomial functions, and really the whole point of this is we're going to use something called the location principle. Now, I'm not a big fan of these notes, but essentially what that says, if you couldn't see the graph, okay, if all you could see is this table, and you're just looking at the y's, right? Notice that from here, I'm actually, as x goes up, right? So I'm going from left to right, essentially. If you look at this, I'm going from left to right. So as you go from left to right, notice that this y coordinate is 35, and then this one is -2. So what we're saying is, if you have a coordinate that is -2, +35, right, which would be way, way, way up here, and you have another coordinate that's -1, -2, which is right here, and then what the location principle says, if you have a point here and a point here, one above and one below the x-axis, right? Above the x-axis, below the x-axis. Then that must mean that there's a root, at least one root between those 2 points. Okay? So if all you had to look at was the table, and as you're looking at the table, you're just trying to see where does the y coordinate switch from positive to negative or negative to positive, right? So, and if you look right here, between 1 and 2, the y's went from negative to positive, so you must have at least another root between those two. And you can kind of see that, right? So my roots are between -1 and -2, which are these two right here, right? And then I have another root between 1 and 2. Okay. So the reason I said I'm not a big fan, because I think if you're going to graph each function by making a table of values, that's incredibly tedious, right? So for part of this, we're actually going to use the calculator to look at it. All right, so now this one I went ahead and graphed it, and I set the table out for you. Okay, if you look at it, notice that right here you went from negative to positive. All right, so you have at least one root. Now this one right here is a little bit different, because this is 1, 0. If you have a 0 for y, that means that is a root. That's actually the exact root. Okay, and then after that you went to 1. So on this one, as I was looking at just the table, I wasn't really sure if it went through it or it was just a double root. Now as I actually looked at it, okay, as I actually looked at this function on my calculator, it turns out that this right, it actually goes through 1 barely, and it goes below the x-axis and it goes up. But I'm not going to be able to see that if I'm going up in increments of 1 as I go. So, all right, so just be careful of that, right? Essentially, if you were ever to have a test, a lot of the times they'll just give you the table and then ask you to approximate where the roots would be located, or in this case they call it the 0 of the function. All right, so let's take a look at this one. All right, now on this one right here, as x goes up, right, as you're going from left to right, notice that you went from positive to negative, so there must be a root between -1, which is right here, and 0. Okay, and then when you went from 1 to 2, you actually have you went from negative to positive, so you must have another root at between 1 and 2, which is between this point and that point. Okay, now I'm actually going to go ahead and graph it so you can actually see it. So I know that at least I have 2 roots just by looking at the table. And so as I graph it, okay, there it is. All right, so I actually have, let's see, I think I got this number wrong. I must have. Let's see, let me look at the table. Maybe I typed in something wrong. See, we have -1, -6, 0, -5. Should be a -6. Okay. Because you can actually see, if you look at this table that I have on my calculator, all right, look at this number between, so the root is actually between -2 and -3, because the y coordinate goes between -5 and 22. Okay, so I actually got that little part wrong here, but you can actually see it again. Notice you went from positive y to negative y, so you must have at least one root there. And then right here you must have a root between 1 and 2, because it went from negative to positive, right? So if you graph it, that's what it would look like. Okay, so I'm not actually going to graph that on here. I think that's just kind of pointless. All right, on the next one, on number 3, okay, so I'm actually going to go over here and then turn that on, assuming that I did the table right. So let's look at the table. All right, notice that right here I went from negative, which is right here. I actually wrote those numbers correctly this time. It went from -0, -1. So I have at least one root that's right here, -1, 0 for sure. If y is equal to 0, I have one root. And this one, I have another root right here. Now, it's not clear just by looking at this if this is either a double root or a single root. You really don't know. All right, it doesn't really give you that much. So let's just take a look at it. Alright, so apparently have a double root here and a double root here. So one a negative one a positive one, like we talked about it. Okay, and then finally let's do this number 4 here. So let me go to this one right here. Let me turn this off, turn this one on, and let's look at the table. Alright, if we look at the table, alright, notice that I have the y values here. The y values are negative, 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 and all of a sudden you will go from negative to positive. So right there you must have a least, you went from negative to 0, so never mind. This actually has a root at negative 1, 0. Alright, 0, 4, remember that's not a root, that's just the y coordinate. Let's see. So at least from what I can tell, I only have one root that I can see, which is negative 1, 0. Oh, excuse me, is this one right here. Let me go up. Let's see if it went to a negative number here. Nope. I went from negative, negative to positive, 2, 0. Okay, so I have another root at 2, 0 also. And I just wasn't able to see that. Alright, so 2, 0, I have another root. So I have one root there, one root there. I honestly don't know if it's just I only have those two. This could be a double root. I don't know until I actually look at the graph. Right? So, but the main thing, remember, the main thing we're trying to learn is if you're looking at the y coordinates, you're looking for 3 things. If the y is 0, that is your exact root. But if you go from positive to negative, like we did on this one, right? I went from negative to positive, or vice versa, then you also have a root between those two x values. Okay, so let's take a look at that. Let's see what that looks like. Okay, so it looks like this one was a single root, and then this one was actually a double root at 2. Alright, so that's essentially what you're doing. All you're doing on this one is trying to figure out where do you have a change in signs on the y. If it changes signs on the y, that means that you actually went through the x-axis. Alright, so let's do the similar thing here. Now, the next thing, we're going to talk about a relative min and a relative max. And a relative min, essentially, and it's easier for me to kind of show you what it looks like. A relative minimum, this would be considered relative minimum, and this would be considered relative maximum. Now, don't get that confused. It doesn't mean that this is the lowest point in the graph, because after all, we know that this graph keeps going down, right? And this graph keeps going up. So that's not necessarily the max, like the max y coordinate here. But what that's saying is that if you are going from increasing to decreasing, that's going to be a maximum, and if you go from decreasing to increasing, that's going to be a minimum. And if you're looking at the graph, you're just looking for these peaks for the maximum, and you're looking for these valleys for the relative minimums, okay, which actually becomes sort of a big deal in calculus. But for now, that's all you need to know. If it looks like a little mountain, that's a max. If it looks like a valley, that's a min, relative min. All right, if you were looking at the graph, all right, if you were looking at the graph, notice that this x values, you're going up, right? Those x values are going up. So if you're basically going from left to right. Now, if from left to right, I go to 22, 29, then back down to 24, all right? So you essentially did this. You're going up, okay, 29, then going down. This must indicate that there's a relative maximum between those two, all right? Because you went up and then you went down. And similarly here, if you look at it, all right, well, right here you have a root or a 0 because you went from positive to negative, okay? And then right here, you kept going. Notice that you're going down, 24, 13, 22, so you're actually going down, and then you're still going down, and then all of a sudden you go up, right? This is bigger than that one, so you actually must have, you were going down, 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 and then all of a sudden you go up. So that's a relative minimum. So if you're looking at the table, that's what you should be able to tell. All right, again, if you see a change in signs, that means that you must have gone through the root. And if you go from, if the y coordinate goes from increasing, right here it's increasing, to decreasing, then you must have a relative minimum somewhere there. And then similarly for this one, if you're going from decreasing to increasing, notice that you're increasing between those two, you must have a relative minimum. All right, so enough about that. So on this one, they're just straight up asking you to graph each polynomial. All right, so if I graph my polynomials, and I actually already have them here, and yes, I would recommend to use a calculator. Otherwise, this would be a pretty tedious. This is not that bad. but other ones can be pretty tedious. All right, so if I go ahead and graph this, all right, I'm going to graph it. Looks like that. Well, I'm just going to show you on here. If this right here would be a relative max, and this right here would be a relative min. All right, and if we were just talking about, let me draw you the picture first, then we can, oh, let me see, around 2 or so. All right, it says right here, they want to know the x-coordinate, which you have a relative max or relative min. So we have a max at x is equal to 0, and we have one at approximately, kind of in between those two, right? So, I don't know, I would say like 1.5 or 2. I'm going to call the relative minimum 2. Alright, so relative minimum at x is equal to 2. And you can kind of see that better on this graph, better than mine, alright? Notice that the minimum would be kind of located at 2. Alright, so again, if you're looking at the graph though, notice that you're decreasing, all of a sudden it's not decreasing anymore, then you kept decreasing, right? So you went decreasing, nothing, and then decreasing again. And as you go here, so this is decreasing, let's see, decreasing, that's actually increasing at this point. Yeah, I'm sorry, I said that backwards. This is increasing, or it says increasing all the way to here, then nothing's happening here, it says 0, 0, meaning it's actually flat at that point, and then it goes down again, so it went down, so this is actually a max. You went from increasing to decreasing, so there's your max. And then right here you went from decreasing, right, you're actually decreasing between 1 and 2 to nothing here, and then going up again. So you basically went from decreasing to increasing. And by the way, there's your root, and there's another root. So anyway, we're gonna just go on with that, and then on the next one, same deal, graph it on your calculator, and this is the last one I'm gonna do for this lesson, and I'm not gonna be so wordy. So let's just worry about the graph, right? So let's take a look at the graph. That's what it looks like. So notice that on this one, all right, on this one right here, you actually have a relative max right here and a relative min right here. All right, I would say the relative max right here would be at around 1. So I'm gonna write max, and I guess I did that earlier so I knew what to graph here. My relative max is at x is equal to -1, and my minimum is actually, I would say, around 0.5. So that's essentially all you're doing with this. This one's not that bad. They're just trying to make you recognize what is a relative max and what is a relative min.